The Agile, AI-driven business enterprise. To thrive in the smart technology era, businesses need to be nimble, which enables business to cope with continuous change in an increasingly complex, rapidly shifting, uncertain, and unstable world. This agility is key for businesses to survive and thrive sustainably with today's marketplace. The following 3 laws for operating in an agile fashion describes the key ingredients in this regard. The law of the small team, where work should typically be done with small autonomous cross-functional or interdisciplinary teams on relatively small tasks in short cycles with continuous end-user feedback. The law of the customer is laser-focused on delivering continuous new value to the customer and make the necessary organizational changes to support this. And the law of the network, where the whole business is truly agile and seen as a fluid and transparent network of high-performance teams that are collaborating towards the common goal of delivering superior value to customers. As companies apply the 3 laws of agility, the actions that promote scale in AI also creates a virtuous cycle where interdisciplinary teams initially start collaborating with their diverse skills and perspectives, combined with the user input needed to build effective customer solutions, absorb new collaborative practices across the business, and move from trying to solve siloed problems to completely reimagining business and operating models. The more the business adopts the test and learn agile approaches for AI-driven pilots and solutions, the faster innovation happens across the organization, with decisions augmented by AI also happening faster and closer to the coalface. AI-driven businesses that operate in such an agile way creates a competitive edge for them in the marketplace. As we have seen with the coronavirus pandemic, a case can be made that only agile businesses will survive. It further accentuates the importance of agility in the smart technology era, where we see new ways of working, living, playing, and learning where everything is different. So, businesses either adapt or die whilst they are continually bombarded with a stream of strategic opportunities and risks, whereas the business agility needs to be constantly upgraded. Steve Denning, in The Age of Agile, argues that strategic agility either occurs as a byproduct of operational agility or using an explicit playbook to generate market-creating innovation. As a byproduct of operational agility, it works well to improve existing products for existing users, but has limitations in not necessarily attracting non-users, eliminating features, and not adding or improving them, leading to cannibalization of other existing products or services. Not a solution for innovation that requires substantial technical innovation or financial investment. A bias for small bets that generate quick wins as opposed to big bets, and dealing with large investments in a new product. The Innovation for Impact Playbook, pioneered by Kurt Carlson and others at SRI International, describes an organizational design and value creation process for creating major breakthroughs, such as what SRI did with HD TV, Siri, and Intuitive Surgical. The explicit playbook for creating market-creating innovation is just as relevant for AI-driven digital transformation of a business and touches on the need, understand non-customers, study markets to identify the need, and think big, but process incrementally. Approach: thinking platforms, acquiring smart digital competency, have a bias for action, create the secret sauce from an existing strength, and separating customers and end users when it makes sense to do so. Benefits per cost for both the customer and the producer. Tell not only what difference, but how much of a difference your solution will make in the life of the customer. And identifying the competition and alternatives. There are always competition in whatever shape or form. To thrive as a business that generates market-creating innovation, continual iteration over this whole process, summarized in a mnemonic NABC, is needed to strengthen the value proposition, assuming that the customer's need is genuine. Assisting businesses on their AI-driven transformation journeys. As businesses are grappling with tremendous challenges to not only be operationally and strategically agile, but to focus on the right use cases for quick wins and optimal business value generation, their data ecosystems, their technology and tools, their people, and the processes they implement. They often reach out to a variety of companies across the AI solutions, consultancy, hardware, and software landscape to help them on their AI-driven digital transformation journey. From a software perspective, we are living in the application programming interface (API) economy, where a variety of commercial, open source, and proprietary components, frameworks, APIs, and libraries are available in a similar way as legal blocks to be used in developing and delivering impactful AI-driven solutions. Technology giants such as Google, Amazon, and Microsoft, and many others are providing scalable cloud computing, hardware, storage, tools, solutions, applications, software components, APIs, and so on via a variety of business models such as infrastructure as a service, which is cloud-based services, and pay-as-you-go for services such as storage, networking, and virtualization. Platform as a service, which is hardware and software tools available over the internet. Software as a service, which is software that is available via third party over the internet. And on-premises software that is installed in the same building as your business. Whereas with infrastructure as a service, the business manages the applications, data, runtime, middleware, and the operating system, and others manage virtualization, servers, storage, and networking. With platform as a service, the business only manages the applications and data, and others the rest of the services. On opposite ends, you have software as a service, where others manage all these services, and on-premises, where the business itself manages all aspects. Goldman Sachs Global Investment Research has highlighted enablers to assist businesses on their AI-driven transformation journeys, which involves do-it-yourself enablement, consulting services, or making use of AI as a service offerings. With do-it-yourself enablement, businesses that have in-house AI talent and differentiated data typically make heavily use of an AI stack that combines open source and cloud provider services. As people with deep experience and knowledge in AI and its applications are not readily available, many companies depend on partnering with AI solutions providers and consultants to help them fast-track delivery of AI solutions. AI problems can also be outsourced to data science competition platforms such as Kaggle and Zindi. The third enabler is AI as a service, where AI-related APIs that have already trained models behind it, or even end-to-end AI platforms for data science and AI applications, are used from providers such as Google, Microsoft, or Amazon. Google, for example, have not only specific AI and machine learning APIs, such as Vision AI, text-to-speech, Dialogflow, and AutoML, but also industry solutions. A recent The Next Web article states that the AI landscape is shifting from data to knowledge and believes that AI's future depends on moving the focus from proprietary datasets to the sharing of data across entities for knowledge creation. They believe that a good knowledge strategy consists of building knowledge moats rather than data moats, using AI in a top-down manner and structure businesses around the application and product layer, combining data, AI models, information, storage, and computing power, shaping organizations' HR strategy through this shift to knowledge, and viewing data acquisition initiatives as a short-term tactical pursuit, while knowledge-based partnerships for cooperation and exchange should be promoted and developed as long-term business strategies. Having been actively involved in AI product and platform developer and AI solutions provider capacity for many years, we also had to adapt very quickly to provide the most effective and efficient ways of providing an AI engine for business that solves strategic and operationally relevant problems through operationalizing AI, data science, Internet of Things, and big data and analytics, and delivering state-of-the-art AI-based applications, solutions, and products. This should typically be done in a practical, cost-effective way, using all available data and smart technology in an end-to-end full-stack, integrated, scalable, and secure manner. These AI-based solutions address business value drivers that lead to an optimized business, a satisfied customer base, productive employees, and smart systems to help accelerate decision-making, innovation, collaboration, and growth. The focus is therefore on business outcomes, such as increased productivity and revenue, reducing risk, lowering costs, creating strategic value, enabling smart automation, enhancing customer experience, and implementing more targeted sales and marketing. Some of these AI-driven solutions include strategic business transformation and optimization, human capital valuation and employee profiling, intelligent virtual assistants, robo-advisors, process optimization, real-time causal analysis, predictive maintenance, fraud detection, churn prediction, advanced risk scoring, machine learning-based trading, real-time customer insights, smart recommendations and purchase prediction, personalized search, cybersecurity, medical risk prediction, and precision medicine. These types of AI-based solutions can be applied in financial services, healthcare, education, retail, telecommunications, resources, utilities, and the public sector, as well as other industries where the automation of tasks and data monetization can lead to economic benefit, scalability, and productivity. To use my AI company Cortex Logic as an example, although now focus on AI-driven platform solutions in healthcare and financial services, we have worked across multiple business and industry domains, seeking to augment and automate legacy processes, ultimately transforming them into intelligent systems using the Cortex Logic AI engine. The 4 core solution domains, each with a range of products that can transform key business processes using AI, includes Engage, that helps people and businesses work smarter at scale. Personalize, which focuses on smart personalization of consumer products and services. Enhance, that provides smart automation and enhancement of business processes and systems. And Sense, which enables smart machines to sense and interpret the world around us. To help businesses with operationalizing AI and unlocking the value from all available structured and unstructured data, an AI solutions provider also needs a highly skilled team of artificial intelligence and machine learning experts, data scientists, data and solution architects, data engineers, business intelligence engineers, business analysts, software developers, domain experts, and out-of-the-box thinkers. As a high-performance team with deep expertise and experience in AI and its applications, as well as the ability to connect the dots in the smart technology era and new economy, they must leverage their speed, agility, and flexibility to develop and deliver scalable end-to-end AI-driven solutions and licensed products. This can be strengthened over time and has many layers within technology: the AI technology stack, solution development, application domain expertise, business models, route to market, partnerships, sales channels, commercialization, and so on. A typical high-level application stack for AI solutions consists of a raw data layer, a data preparation layer, a smart data layer, an analytics layer, and an application layer that are in a continuous loop of refinement and improvement. The raw data layer, which consists of a variety of data sources that can, for example, be structured, unstructured, or streaming data, typically feeds into a data preparation layer where data can be extracted, transformed, and loaded, along with other data preparation such as natural language processing, text analytics, and entity extraction. These 2 layers are followed by a smart data layer that handles a spectrum of big data, smart data, knowledge bases, SQL databases, NoSQL databases, resource description framework data, ontologies, and ecosystems that become enterprise data hubs. The next layer is an analytics layer that covers the spectrum of analytics such as descriptive, diagnostic, predictive, prescriptive, and cognitive analytics, which uses a variety of algorithms such as various machine learning algorithms. The final layer is the application layer that addresses application engagement, the user interface, the user experience of the user interface, insights, and recommendations. The data science methodology typically used in delivering AI-based solutions follows a combination of sequential execution of tasks in certain phases and highly iterative execution steps in certain phases. Because of the scale issue associated with a big data and analytics system, designers must adhere to a pragmatic approach of modifying and expanding their processes gradually across several activities, as opposed to designing a system once and keeping the end state in mind. The main phases are typically as follows. 1. Analyze and evaluate business use case. 2. Develop the business hypothesis. 3. Develop analytics approach. 4. Build and prepare data sets. 5. Select and prepare the analytical models. 6. Build the production-ready system, scale and performance. And 7. Measure and monitor. The methodology also corresponds with the cross-industry standard for data mining, or CRISP-DM, and the Analytic Solutions Unified Method for Data Mining and Predictive Analytics, called ASM-DM. CRISP-DM has a cyclic nature and prescribes a sequence of phases that are dependent on one another and starts with business understanding, which is followed by data understanding, data preparation, modeling, evaluation, and deployment. The sequence of CRISP-DM phases is not strict, and moving back and forth between different phases is always required, especially between business and data understanding, data preparation and modeling, and evaluation of the models against the business understanding and desired outcomes. A data mining process continues after a solution has been deployed. The lessons learned during the process can trigger new, often more focused business questions, and data mining processes that follows will tap into the experiences of previous ones. The business understanding phase focuses on understanding the project objectives and requirements from a business perspective, and then converting this knowledge into a data mining problem definition and a preliminary plan designed to achieve the objectives. A decision model, especially one built using the decision model and notation standard, can be used. The data understanding phase starts with an initial data collection and proceeds with activities to get familiar with the data, to identify data quality problems, to discover first insights into the data, or to detect interesting subsets to form hypotheses for hidden information. The data preparation phase covers all activities to construct the final dataset, data that will be fed into the modeling tools from the initial raw data. Data preparation tasks are likely to be performed multiple times and not in any prescribed order. Tasks include table, record, and attribute selection, as well as transformation and cleaning of data for modeling tools. In the modeling phase, various modeling techniques are selected and applied, and their parameters are calibrated to optimal values. Typically, there are several techniques for the same data mining problem type. Some techniques have specific requirements on the form of data. Therefore, stepping back to the data preparation phase is often needed. At the evaluation phase of the project, you have built a model or models that appear to have high quality from a data analysis perspective. Before proceeding to the final deployment of the model, it is important to evaluate the model more thoroughly and review the steps executed to construct the model, to be certain it properly achieves the business objectives. A key objective is to determine if there is some important business issue that has not been sufficiently considered. At the end of this phase, a decision on the use of the data mining results should be reached. The development of the model is typically not the end of the project. Even if the purpose of the model is to increase knowledge of the data, the knowledge gained will need to be organized and presented in a way that is useful to the customer. Depending on the requirements, the deployment phase can be as simple as generating a report or as complex as implementing a repeatable data scoring, for example, segment allocation or data mining process. In many cases, it will be the customer, not the data scientist, who will carry out the deployment steps. Even if the data scientist deploys the model, it is important for the customer to understand upfront the actions which will be needed to be carried out to make use of the created models. ASM-DM also has a cyclic nature and shows more the broader data mining lifecycle and project management perspective, with the first major analyze, design, configure, build project phase that is followed by the deployment project phase and then the operate and optimize project phase for the same deployed AI solution. To deliver end-to-end AI-based solutions, an AI engine can be developed that typically consists of components that enable rapid access to all available data and the preparation of smart data, the automation of the AI solutions, and the integration of the AI solution into the business processes and/or customer interfaces. Enabling smart data for automated AI solutions involves providing a solid data lake and warehouse infrastructure that can not only deal with the volume, velocity, and variety of structured and unstructured data, but also enable rapid access to all data via flexible data models, data preparation, and smart data layers for analytics and automated AI systems. It should support polyglot persistence, which implies using multiple data storage technologies for varying data storage needs, and facilitate access to various source systems via data virtualization, distributed processing, and other system components. The multi-platform architecture should also provide a governance model to support trust and security, master data management, data federation, data cataloging, automation, support for all types and levels of users, and the ability to facilitate near real-time analysis on high-velocity data, massive parallel processing, and in-memory compute. The second part of the AI engine is the automate the AI solutions. This type of data and compute infrastructure is essential to operationalize data science and implement automated AI systems where there is significant reuse of feature libraries and data preparation pipelines for generating deep insights via data exploration, analysis, contextualized data, modeling, and predictive models in a development and productionized context. This is done by following international data science standards and implementing automated analytics within a champion-challenger approach, which is typically maintained and kept up to date during the deployment and operational phase. The third component of the AI engine is integrating the AI solutions into business processes and/or customer interfaces. The AI engine ensures that the analytic outputs, scores, and predictions are integrated into the business via an analytics services layer that involves, amongst others, automated analytics dashboards, intelligent assistants, a range of deployed models, simulation and optimization service, and real-time machine learning. The integration into business processes involves, for example, on-demand delivery models via Access Anywhere analytics services and context-aware business applications, push delivery models via alert and response and location-based services, and embedded delivery models via workflow and interaction automation and smart devices and systems. The outputs of this integration can then be stored back in the data lake.